Hello, welcome to lesson 4 on the topic permutation combination. If you remember, in lesson 3 we were looking at the applications of combination. We would like to continue doing that and look at some more applications. Another application of combination is the number of straight lines that can be drawn. The number of straight lines that can be drawn. Suppose there are n points on a plane. Suppose there are n points on a plane and no 3 points are collinear. Okay? Suppose there are n points on a plane and no 3 points are collinear, then the number of straight lines that can be drawn will always be NC2. What is the logic? The logic is same as what we had discussed for the number of handshakes or the number of matches played in a round robin tournament. Just like for the handshakes and for the matches, for us to draw and define a straight line, define and draw a straight line, we need 2 distinct points. So the number of ways in which we can select 2 points out of n distinct points will be equal to the number of straight lines that can be drawn. Let me give you an example. Suppose there are 5 points on a plane, right? That means we are actually talking about a pentagon, right? Suppose there are 5 points on a plane and no 3 points are collinear. Let us see the number of straight lines that can be drawn. As per what we are saying, it should be 5C2. And what is 5C2? It is 5 into 4 upon 1 into 2. That means the number of straight lines that can be drawn should be 10. Let's check this. This is 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So the number of straight lines that can be drawn is nothing but an application of NCR. Now if you looked at the statement, in the statement we said that no 3 points are collinear. That means amongst the given points, no 3 of them should be in a straight line. So let us look at a different aspect of point number 2. What if some of the points are already on a straight line? Then what will be the thought process and how will we do that that question? Allow me to take out this particular part. So we have already discussed this. Now all right, now suppose there are n points out of which m points are collinear, right? There are n points on a plane out of which m points are collinear, and here we are saying that m is greater than 2. Because why we are saying more than 2 points? Because 2 points are always going to be collinear. I hope you understand and appreciate that. So here we are talking about what if there is a situation where more than 2 points are collinear. First, let's talk about what is the concept. Let us understand this, and it's beautiful, it's very logical if you look at this. All right, start with the thought process. What if all these n points had been like the last case? That means not more than 2 of them would have been collinear. Then the number of straight lines that would have been drawn will be NC2. Correct? This is what we had done just now, some time back. If no more than 2 points had been collinear, then the number of straight lines would have been NC2. But here what is the situation? The situation is m points, out of are already in a straight line. Now, please think about this. All the straight lines that these M points would have formed amongst themselves, they will not get formed. I will repeat this statement once again. All these M points which all these straight lines which these M points would have formed amongst themselves will not get formed. So they will have to be subtracted, right? I hope I am making sense. So NC2 minus MC2, alright? But when you do this, please appreciate, you are subtracting all the lines including the line on which these M points are already lying. Okay, you are subtracting all the lines, fair enough, but you are also subtracting the line on which these M points are already lying. That line has to be counted, and therefore the number of straight lines will be NC2 minus MC2 plus 1. Okay, so if you remember, towards the beginning of our discussion on permutation combination, I had shared with you that PNC as a topic is absolutely logical, provided I know that it is logical and I know how to approach it and understand the concepts. So what is the number of straight lines in this case? NC2 minus MC2, you know why we are doing this, and then plus 1. Can we take an example to see this? Okay. Now let us take an example where we are talking about the same 5 points. But now what is the case? So we have 1, 2, 3, and then we have 4, and then we have, suppose we have 5. Right? So what is the situation? 5 points, out of which 3 of them are already on a straight line. Now before I draw the number of straight lines, what will be the value? It will be 5C2 minus 3C2, because these 3 points, all these straight lines we are subtracting, plus 1. What is 5C2? 5C2 is 10. What is 3C2? 3C2 is 3 and then plus 1. So this is 7 plus 1. That means the number of straight lines that should be now drawn, should be possible to draw, is 8. Let us check this. So this is 1, 2, 3, 4, 5, 6, 7, and this line on which all of them are lying. So this is the 8th line. Now this is the line for which we are adding this plus 1. Alright. So NC2 minus MC2 plus 1. Alright. This is the second application of a typical application of combination. These are all popular questions that get into many of the competitive exams and placement process. If not directly, then at least as part of the concept. Okay. Now let me give you the third application. If we have identified, or if we have understood how we are talking about the number of straight lines being drawn, then the same concept can be extended to talk about the number of diagonals. Okay, the number of diagonals. So if a polygon is any figure which has got a number of sides. Poly means many. So if a polygon has n vertices, then the number of diagonals will be NC2 minus n. Then the number of diagonals will be NC2 minus n. Alright? What is the logic? What is the concept? We have seen that if there are n vertices, the number of straight lines will be NC2. Alright? The number of straight lines that can be drawn will be NC2. Will all of them qualify to be the diagonals of the polygon? No. right? Because n of those straight lines will be used to form the sides of the polygon. N out of those NC2 lines will be used to form the sides of the polygon. So what will be the number of diagonals? The number of diagonals of the polygon will be NC2 minus N. Okay. Now let us take an example. Suppose we say that we are talking about a hexagon, right? For a hexagon, the number of diagonals will be equal to 6C2 minus 6, right? So what is 6C2? 6C2 is nothing but 15. 15 minus 6, that means a hexagon will have 9 diagonals. Let's check this out. So we are talking about a figure like this. You all know this is a hexagon. Let us see the number of diagonals. All right. So this is 1, then this is 2, 3. Here we will not have. Another line 4, the fifth line 5, the sixth line 6. Then from here I already have this, the 7th diagonal, the 8th diagonal and the 9th diagonal. Alright. A very popular question. I remember very clearly last year in one of the placement papers there was a direct question. How many diagonals will a decagon have? You all know that a decagon is a polygon, is a regular polygon which has got 10 sides. So you can very easily find out the number of diagonals of a decagon, right? Now towards the end, before I close this, have we ever thought of how many diagonals? What is this? This is a triangle. How many diagonals does a triangle have? We all know that a triangle does not have any diagonals. What is the explanation? The explanation is very simple. If there are 3 points, the number of straight lines that can be drawn is 3. The number of straight lines that can be drawn is 3. Now, interestingly, all 3 of those straight lines will be used to form the sides of the triangle. So, how many straight lines can be formed with 3 points? 3 straight lines. All 3 of them will form the sides of the triangle. So, how many diagonals will a triangle have? A triangle therefore does not have any diagonal. I hope you all have understood these applications of combination. Thank you.